Hi, my name is Nicole Matabarbosa, and this is my video of the last project of the Inspire Control in the Master of Automation and Control. This is the genetic algorithm. For the genetic algorithm, we need to develop a general code and objective specific code. The specific code is the fitness function. In this part, we need to find the transfer function with a database, with a specific database. Alright, this is the genetic algorithm. The first part is the importing libraries. The NumPy import EMPINB for the fitness function, the matplot, and the IPython for the clear the output, and only C1, the last one. And next this we have this part. This is the graph of my database. My database is about a temperature in the blood when put in a centrifugate blood. Okay. Next is we have the class generation for the population. In this part, we create the parents with the N chromosomes and the N alleles. Next is we can see the tournament selection. In this part, we selection the winners previously created. After this, we have the crossover operation. In this part, we obtain the new parents. We have the cruza or crossover. After this, we have with this offspring, we obtain the operation mutation. The mutation is for evaluate the best fitness in the best parents or individual. Next is, we have the definition, the range, the generations, we have the first parameters about the chromosomes, allele, generation, tournament sites, and PM. In this case, we have 1000, 2010. We have this part for the plot, and with we have in this part 2000 generation, and for this the best fitness is this, the worst fitness is this, and the final result is this part. In this part we can see the transfer function with the best chromosome in the system. In this part we have the gain, the time constant with these values, and this is the comparison between the transfer function real and the desired response. The desired response is the line orange, and my transfer function real is the line blue, the blue line. Yes, obtained the orange and desired the blue. After this, we have the same behavioral of the database, and after this, we have the fitness across generation. With 2000 generation, we have this part. With this, we need to obtain or use the fitness function for the evaluation each chromosome, each allele, and all this part of the process. In this part we have the same the libraries in the definition of the function to binary to decimal of the chromosome and alleles with a resolution of 200, offset 0, the value. After this, we have the moving average. After the step info is like the reference or the part that the program try to follow. After this, we have the part, in this part, the read data of the transfer function or the database. In this case, my database is called demo. After this, we have the definition of the fitness function. In this part, all the previous data evaluate in this part. And in the finish, we have the delivery result. Only return the best selection of this, and with this we can obtain the transfer function in a genetical algorithm. This. Well, in this part we have the particular swarm optimization for a transfer function. In this case, we have this part is PSO. Is the in theoretical we have the same part of the same structure of the other genetic algorithm. We have the libraries, the definition of the function to the initial number of particles, dimension, max, min, C1, C2, W is the concept of the inertial, and the ET. Well, we have all the structure for this, all the structure for this. After this, only we have the principal values for the number of particles, dimension, max, min, W, ET, C1, C2, and in this part we call the function PSO. For this, we need to put this part. Well, in this part we have the NumPy, the moving average, the step info, and the read database. It's something like that of the previous program. The evaluation of the PSO with the ghost, with the readings SCB, and we finish with the delivery result. The same. Well, with this we can obtain the best result, and for this we have this part, the best cost, and this is the transfer function. The gain and the tau is the time, well, desired, the across generation, the transfer function real versus the desired response, and the graphic of the database. Alright, well, in this part we can conclude that we have best response in the PSO, and in this part we have only 89 iteration or repetition, and with this only 89 iteration we have this part of the transfer function, and with this transfer function is more best of the transfer function that obtained with the genetic algorithm, because with the genetic algorithm we have 2000 generation and is more slow, and with the PSO is more fast. Well, thank you for this, and this is all.